This is concept learning. This is hypothesis space. Basically, we have certain attributes which we can observe. Okay, we can observe that the sky can either be sunny or rainy or cloudy. We can observe that the air temperature around us can be warm or cold. We can observe that the humidity can be high or normal. We can observe that the winds can be strong or weak. We can observe that the water temperature can be warm or cold. We can observe that the forecast can remain the same or change. And based on this, we also observe a person who goes out or does not go out to enjoy the sports. Okay. So, what we want to find out initially, we want to find out which of these attributes affects whether the person enjoys to play sports or not. Okay. So we start with an initial assumption, that is the null hypothesis. That is, none of these attributes affect whether the person goes out to enjoy sports or not. So that is our initial null hypothesis. Okay. All of the attributes are null, and still, of course, the person either goes out or does not go out to play the sports. There cannot be a third possibility. Okay. So that is the null hypothesis. Then we see the first row. When we see the first row of our data, we see that yes, when the sky is sunny, when the temperature is warm, when the humidity is normal, when the wind is strong, and when the water is warm, and the forecast remains the same as forecasted and does not change, then yes, the person does enjoy to go out for sports. Okay, this particular representation is called as a long whistle. So this particular representation is called as a conjunction of constraints. Conjunction of constraints means, what are the constraints here? Sky equal to sunny. Sky has to be sunny, temperature has to be warm, humidity has to be normal, wind has to be strong, water has to be warm, and forecast has to remain the same. Only then the person goes out to play the sports. And we are using and, so that's why it's conjunction. So sky is sunny, and the temperature is warm, and the humidity is normal, and the wind is strong, and the water is warm, and the forecast remains the same, then the person does go out to play the sport. So this is conjunction of constraints. This is after seeing the first row. Then we see the second row, third row, so on, and we build some kind of a machine learning model, or basically some kind of a model. Okay, so let's say we build a decision tree model. So let's say this is the model that we build. We have studied ID3, we have studied CART, and let's say by using the mathematics, using either entropy or the Gini impurity, we get this particular tree, decision tree. Now what does it mean if I have to represent this tree as a conjunction of constraints? This will mean, for example, if I consider the leftmost child, that is sky is rainy, sky equal to rainy, temperature equal to warm. But what about the other attributes? The value of the other attributes don't matter. The value of the other attributes don't matter. The label will be no. The person will not go out to enjoy the sports when it is raining and the temperature is warm. Okay. Similarly, now I will take the extreme rightmost child. Sky equal to sunny. Now when the sky is sunny, irrespective of what values the other 6 attributes have, the person always goes out to play or enjoy the sports. Is this based on the limited data set given over here? No. This is hypothetically assuming there are 10s, 20s or hundreds of rows in the data set, and assuming that, okay, based on that data set I train and get this particular tree. I am assuming that. Okay, so let's assume, my assumption, let's say after training for hundreds or thousands of such rows, we get this particular decision tree. So this is the interpretation of this particular decision tree in terms of conjunction of constraints notation. Now if someone asks you, what is the instance space? What is the instance space for this particular problem. The instance space will be what all combinations of the 6 rows, so the 6 columns, sorry, not rows, the 6 columns, 6 attributes, what all possible combinations of 6 attributes can you have in your training data set. Okay, in your training data set, sky can take one of 3 values, although here in this limited snapshot, here you can only see sunny or rainy, but the sky can also have cloudy, sky can also be cloudy. Okay, so it can be clear sky, sunny, or it can be cloudy, or it can be rainy. So sky can have 3 values. Then temperature can be warm or cold, so temperature can have 2 values. Humidity can have 2 values, it can either be normal or high. Wind also, in this limited snapshot you can only see strong, but wind can also be weak in a larger instance of this problem. So wind can have 2 values, let's say. And water can only be warm or cool, let's say, so 2 values. And forecast can also have 2 values, it can remain the same or it can change. Okay, now we'll use simple counting principle, basic counting principle of multiplication, basic multiplication principle. Okay, so if we are forming a row of the training data, we first have to choose the value for sky. We have 3 choices for sky, and we also have to choose something for temperature. We cannot leave it blank like we did over here. This is conjunction of constraints. This is not an instance, this is conjunction of constraints. Our instance space, that is training data rows, basically training data rows. So training data will not have any missing attributes. If training data has missing attributes, it is a problem, right? We have to clean that, we have to do data pre-processing, right? We don't leave missing values. If there are missing values in our training data, then we either use imputation, we use something to fill those missing values, or we don't consider those rows or something like that. Okay, so temperature, we need 2 values. Okay, so we have 2 choices for temperature, so we need one of those 2. So there are 2 ways we can fill the temperature, there are 2 ways we can fill the humidity, there are 2 ways we can fill the wind value there are 2 ways we can fill the water value over there, and there are 2 ways we can fill the forecast value over there. So the size of the instance space I, okay, if I call it as I, instance space I, the size of the instance space I will be 96. Now this is the instance space. Now what about the hypothesis space? The hypothesis space is formed like using the conjunction of constraints. So this is the hypothesis. Decision tree is like one of the hypotheses. Basically, in mathematical language we call it as hypothesis. In machine learning language we'll call it as a model. Okay, so one thing is we can have a null model or null hypothesis, that is considering none of the attributes, the person still goes out or does not go out to enjoy sports. So that is one thing. So every attribute can either have null or phi. Okay, and the other possibility is question mark. We don't consider that, as we have seen in decision tree. In decision tree the phi does not arise very naturally, but there are certain algorithms in which we start with a null hypothesis and then we go on considering the different attributes. Okay, but right now just understand that when we are considering the hypothesis space calculation, sky will have not just 3 but 2 additional possibilities, that is either a question mark or a phi, that is null hypothesis. So therefore it will have 5 possibilities and not just 3. Temperature will have 4 possibilities and not just 2, because it can have a question mark or it can have a null. Okay, null hypothesis or does not matter. Okay, humidity can be high, normal, does not matter, or null, so 4. Wind can be strong, weak, does not matter, or null, so it is also 4. Water can be warm, cool, does not matter, or null, it can also be 4. And forecast can remain the same or change or does not matter or null, so it can also be 4. Okay, so basically the size of the hypothesis space, if I indicate it by H, the size of hypothesis space. So basically, if I have conjunction of constraints which I have to fill with six things. Okay, I think here I did not count properly. It should only be okay. It should only be 6, right? Okay, 6 attributes. Okay, so 6 attributes. So first one has to be one of the 5 possibilities for sky, and the second one can be one of the 4 choices for temperature. The third one can be one of the 4 choices for humidity. Fourth one will be one of the 4 choices for wind. Fifth one will be one of the 4 choices for water, and sixth one will be one of the 4 choices for forecast. So this is 256 into 4 . So we have 5 into 4 into 4 into 4 into 4 into 4, which is 5120. So the size of the hypothesis space will be 5120. That's it.